Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students of the General Secondary Certificate, welcome back to your program Madrasa ala al-Hawa. Today, inshallah, we'll continue our discussion about the transition elements. Don't forget that in the last session, we stopped at the properties and the uses of copper and zinc. Today, inshallah, we'll continue the uses, then start the properties of the transition elements. Let's first welcome back your guest and my guest, Mr. Muhammad Abdullah Riyad. Welcome back, Mr. Muhammad.
Welcome.
Today, inshallah, we'll continue our discussion about the uses of transition elements. We stopped at copper and zinc. Then we'll continue the discussion about the properties of transition element. Okay?
At first, sometimes we find a question said that find one uses of copper or zinc or any element. One use only, I can write many uses. Sometimes maybe one of them is not correct. It is allowed to write many uses of copper. Let's to see one uses of the copper.
Here on the laptop, we see the
Yes.
uses of copper. Yes, in making electric wires, in manufacture of tools and equipment, in making coins.
Now, let's to start the first one in making electric wire. We know that copper is a good conductor of electricity, and it causes no change in the thermal effect, has no thermal effect when the electric passes through it. So it is a good conductor of electricity. So we use it in making electric wires. Also we use it in making equipments because copper is a good conductor also of heat. So it is used as equipments and tools. But we know now we use stainless steel. It's better than copper because it's exposed to rust. Now we use stainless steel or another tools or another equipments. Also we use copper in making coins. We know that in coins may be made of copper, made of gold, or made of silver, or mixture between copper with gold as an alloy of gold.
Also, from the uses of the copper in purification of drinking water, in detection of sugar in urine Fehling solution.
We use copper sulfate to detect water. We will study this in organic. Copper sulfate is used to detect water. Also, we use copper sulfate to purify the drinking water. Also, we can use compounds of copper, which is called Fehling A and Fehling B, is a solution used to detect the presence of sugar in urine.
Also, we have here, now we can transfer to the zinc properties, or the zinc uses, I'm sorry, in galvanization.
Galvanization, we know that about 25% of the iron is exposed to rust. In order to keep iron and the other element from rusting, we make a galvanization. Galvanization, we will study this in chapter 4. Galvanization to cover the iron or other metal by zinc in order to keep it from rusting. This is about the galvanization. Another use
in making paints, rubber and cosmetics.
It is used in many uses, such as in making paints. We can use compound of zinc for paint substance, or used in making rubber. Also, we can use it in making cosmetics. We know that a nano of zinc can protect from the effect of the sun rays.
In screens of X-rays,
we can make a screen made of zinc in order to detect the X-ray. So screens of X-ray can made of zinc.
Now we have a give reason here said that chromium and copper are anomalous from the expected electronic configuration?
Of course.
Actually, it's a very important question.
Yes, this is a very important question, as you say. We know that chromium, atomic number 24. We use noble gas argon 18. Though, so 4s and 3d. 4s must be contains 2, saturated by 2 electrons. We know that 4s has less energy than 3d. So we put 2 electrons in 4s before 3d. But here we make 1 electron only in s, and the second electron transfer to 3d to be 5 electron in 3d. When the chromium has 5, let's to say 5 electrons, this means that d sublevel half field of electrons. 1, 2, 3, 4, 5. When the sublevel D has unpaired electron, half field, or completely filled as copper, as we'll explain now, or empty as a scandium positive 3, this will be more stable. The element will be less energy and more stable when sublevel D is empty or contains half filled 5 electrons, or completely filled contains 10 electrons. So when we write the electronic configuration of copper, we make argon 18 for S1, not 2, and 3d5 to be half filled, less energy, more stable. This is about chromium. Also about copper. Copper 29, argon 18, and 4s1, not 2, to put 10 electrons in D. يبقى copper 29, argon 18, 4s1 with 3d 10. Why? To be completely filled the sublevel D. When it is completely filled, it is more stable. Completely filled, less energy, more stable. So in order to make the electronic configuration take care from copper and chromium, we don't put 2 electrons in 4s, but 4s1, 3d5. Why? To be half filled, to be more stable. And the copper will be 4s1, 3d10, not 9. Why? To be completely filled and to be more stable.
Actually, as you said here on the laptop, we have the answer as you write it or you prepare it. Yes, half-filled D sublevel will be more stable, and also it will be, if it is completely filled, it will be also more stable than being D9. Okay, now let's transfer to another give reason. Iron 2 is easily oxidized to iron 3.
Okay, let's explain this in details according to iron and to manganese also. We know that iron 26, electronic configuration of iron will be argon 18, 4s 2, 3d 6. I can write 3d before 4s or 4s before 3d, whatever. But we know that 4s must be filled by electrons before 3d. But I write this according to the arrangement of energy level. The third energy level is 3d, and the 4s and the fourth energy level. When this electron loses 2 electrons to p iron 2, positive 2, it loses electron from 4s at first. Why? Because 4s less energy than 3d. It will be argon 18, 3d6. But when the iron becomes Fe positive 3, it will be argon 18, and loses 3 electrons, 2 from 4s and 1 from 3d. 3d will be 5 electrons, will has 5 electrons. So I said that with the sublevel D half field it is more stable. Iron 3 half field, so it will be more stable than Fe2. It will be less stable because it has 6 electrons in 3d. So it is easy to convert from less stable to more stable. يبقى at first iron 3 is more stable because it is half field. Fe less stable, it is not half field, sublevel D. So it is easy to convert less stable compound to half stable, to more stable. So Fe positive 2, easy to convert Fe positive 3. When the oxidation number increase, this process is called oxidation. We know that oxidation loses electrons or increase the positive charge. So it is easy to oxidize the iron 2 to iron 3. But it is difficult to reduce meaning that decrease the oxidation number. In order to reduce Fe positive 3 reduction to Fe positive 2, this is called the reduction. In order to convert more stable to less stable, it is difficult. Less stable. يبقى it is difficult to reduce iron 3 to iron 2, but it is easy to oxidize or convert iron 2 to iron 3. By the way, about manganese.
Yes, the question has a rest part, said that while manganese 2 is difficult to be oxidized.
By the way,
manganese 3.
Manganese 25 atomic number. It will be argon 18, 4s2, 3d5. So Mn positive 2 will be argon 18, 3d5, half field, more stable. While to oxidize manganese, meaning that convert positive 2, manganese positive 2 to positive 3, this means that argon 18 and 3d4 less stable. So it is difficult to convert more stable to less stable. It is difficult to convert manganese 2 to manganese 3, or it is difficult to oxidize manganese 2 to manganese 3. But it is easy to reduce manganese 3 to manganese 2. Why? Because we convert less stable to more stable.
Thank you. The next question said that transition elements have oxidation number positive 2 except scandium, its oxidation number positive 3. So the scandium hasn't positive 2 oxidation state. Why?
Yes. At first, all transition elements contains 4s2 and 3d from 1 up to 9, not 10 on. We said that when it contains 10, it will be non-transition element. So we said that it loses electrons from 4s at first. So all transition element can give the oxidation number positive 2 when they lose 4s, 2 electrons from 4s. But according to scandium 21, it will be argon 18, 4s2 and 3d1. During the chemical reaction, it loses 4s, 2 electrons of 4s, and 1 electron of 3d. It will be scandium positive 3, argon 18, and S and 3d will be empty, and this will be more stable. It will be more stable. Its electronic configuration similar to a noble gas, argon 18. So it will be more stable, less energy and more stable. Why? Because 3D is empty from electron. So scandium has only one oxidation state, which is positive 3. Also zinc, positive 2 only. It will not be positive 3. Why? Because zinc positive 2 will be argon 18 and 3D10 completely filled and more stable. It is difficult to be zinc positive 3.
Thank you. The next one said that give reason transition elements have variable oxidation states. Actually, it's a specific character for the transition elements.
Yes, okay. Transition element, I said that 3D from 1 to 9 and 4s 2. So it will be positive 2. This is the first oxidation state. Also, it can lose electrons from 3D. This is why, because the energy of 3D and 4s are close together. It can lose electron from 4s and from 3D in sequence. So it will be, when it loses one electron, it will be positive 3. When it loses another, it will be positive 4. Until we reach positive 7 as in manganese. Manganese, we know that. Manganese 25, argon 18, 4s2 and 3d5. It will lose 2 electrons to have the oxidation number positive 2. And when it loses 1 from 3d, it will be 3, valence 3 and valence 4, until it loses all electrons of 4s and 3d, it will be positive 7. So the oxidation number increases from scandium, from titanium as 2 until we reach manganese. Then the oxidation number decreases until we reach zinc, which has positive 2. Except copper. Copper, it may be positive 1, as in cuprous chloride or cuprous oxide, Cu2Cl2. The oxidation number of copper will be positive 1. But all elements of transition element have the oxidation number 2 or more, except also, as we said, scandium, it will be positive 3. This about the oxidation number. So transition element has variable oxidation number because they can lose electrons from 4s and 3d. While the other elements, so what's about the metals? Other metal, for example, when we take magnesium or aluminum, whatever, magnesium, it will be, we know that 12 to 8, 2 electrons for outer energy level. Aluminum will be 2, 8, 3. So it will be oxidation positive 2 when it loses 2 electrons. But it is difficult to lose electron from the sublevel before the last one, L sublevel, because it will be completely filled and difficult to break down completely filled energy sublevel. Also, aluminum will be positive 1, positive 2, positive 3 when it loses the 3 electrons of the outer energy level. It will be 3s2 and 3b1. This is the last energy level of aluminum. So it will lose 2 and 1 to be positive 3. But it is difficult to be positive 4. It needs high energy to break down complete energy level. But in transition element, we can lose electrons from 3D easy to reach the positive 7 as in manganese.
Actually, we have a note said that an oxidation number doesn't exceed the group number, except in group 1b. Shall we explain this note, please, for the students?
When we say the number of groups in these elements, we say that scandium, we start with 3b. Why? Because the scandium has oxidation number positive 3. Then titanium will be 4b the maximum oxidation number of titanium will be 4, and so on. So the oxidation number of any element don't exceed its group. Yet titanium not has oxidation number 5, because titanium 4sc2 3d2, it will lose the 4 electrons to be oxidation number 4. It will not be 5. All elements, the oxidation number start from 2 up to the L group number, not exceeds L group number, except group 1b. 1b, L copper 29, we said that L copper will be argon 18, 3d 10, 4s1. It will be 1 when it loses the electron from 4s, as I said, في الكبرس chloride or الكبرس oxide. But we have oxidation positive 2 when it loses electrons from 3d and the electron of the electron of the 4s. The copper positive 2 will be argon 18, 3d 9. The most oxidation number of copper in its compound positive 2, the more stable in nature positive 2. But the copper may be positive 1, may be positive 2. The copper in group 1b, those oxidation number exceeds its group.
Also gold.
Gold positive 3.
Yes,
positive
gold
3.
positive 3 in the same group of the copper exceed the group number.
Okay.
Okay, the next question said that what's meant by transition elements?
Transition element, we said that when the electron fill the 3d from 1 to 9, these the elements which are found complete 3d, uncompletely filled 3d in free state or in one of its compounds. When the element has electrons in 3d but not completely filled, this is number 1, not completely filled, and in one of its compounds, what's meant by this? I said that when the electron contains, when the electron successfully filled 3d, it will be transition element. Scandium 3d1, titanium 3d2, until copper and zinc. Stop here to explain the copper and zinc. I said that the copper will be argon 18, 3d10 for S1, and zinc argon 18, 3d10 for S2. I said that the element will be transition element when sublevel D is not completely filled in one of its state, in free state or of one of its compound. Here, the copper with zinc in free state are completely filled. But what's about the compound of copper and the compound of zinc? We know that the copper may be positive too, as copper oxide, copper sulfate, copper nitrate. These compounds, the oxidation number of copper positive too. Argon 18 and 3d9, but not completely filled in one or more of its compound. So it is transition element. It is transition element. So when the element is not completely filled in free state or one of its compound, it will be transition element. But all compound of zinc positive 2, there is no any compound of zinc has oxidation number positive 3. So positive 2 will be argon 18, 3d10. So copper is a transition element because it is not completely filled in one of its compounds. Also, silver will gold. Group 1b, for transition element, copper, silver, gold, they are completely filled in free state, completely filled sublevel D. But in one of its compound, it may be not completely filled, so they are considered as transition element. These elements are called, as we say, coinage metals. So coinage metals are transition elements because they are not completely filled in one of its compounds. While group 2b, zinc, cadmium, and mercury, they are completely filled. Sublevel D. Sublevel D has 10 electrons in all states and free states or all their compound. So zinc, cadmium, mercury or group to be considered not transition elements.
Actually, was our next question, but thank you for answering in advance.
Okay.
Now let's transfer to the next point in our lesson, which is the general properties of transition elements. How can we discuss this point with our students, if starting from the atomic mass or the masses, the abundance? What about the properties of transition elements? Could we discuss it firstly?
As we know from the previous studies, the transition elements are metals. We know that metals, all metals are solid except mercury. They have shiny and brightness. They are good conductor of heat and good conductor of electricity due to the presence of free electrons في outer energy level. About the atomic radius of these elements, we know that as the atomic number increase, the positive charge of nucleus increase. So as we move from scandium 21 to zinc 30, I said that zinc is a non-transition element, but as we move in these groups from scandium to zinc, the number of positive charge increase 21, 22 and so on. So the attraction of the nucleus to the outer electron increase. This decrease the atomic radius. This is number one. Number two, adding electron in the sublevel D. D1, D will be 2, D3. This increases the repulsion between electrons, and the repulsion causes increase the atomic radius. So the radius under two forces. Attraction force due to increase the positive charge of the nucleus, and repulsion of the electrons in sublevel D or in the inner sublevels. And these forces, one causes decrease the radius and one causes increase the radius. They are compensate to each other. So almost the radius of transition element are almost equal. There is no big difference in the radius of the transition element. So copper, iron, chromium, iron, cobalt, nickel are almost similar in atomic radius. So they have the same properties. They put in one group. We know that Fe with CO, Ni in group 8. Because they are similar in properties. Why they are almost similar in properties? Because they are similar almost similar in atomic radii. This is about the atomic radius. So the difference in atomic radius, increase the atomic radius through this group, not big.
Let's transfer to the atomic mass, to discuss the atomic mass, then transfer to the density of these elements. So what about the atomic mass?
Atomic mass increase according to increase the atomic number. So the atomic mass increase from scandium also to zinc. Right. Density, we know that density equals mass divided the volume. So density of this element, atomic mass, which increase over atomic radius. We say that atomic radius almost constant, but the atomic mass increase. So density depends on the atomic mass. because the atomic mass change while the radius almost. So the density of this element increases from scandium to zinc.
We have an exception about the atomic mass. We know that
Yes,
the atomic masses
Ni.
increases from scandium to zinc, except for nickel. Why the nickel has got this type of exception?
Nickel has isotopes, 3 isotopes. They are equal in atomic radius, almost equal, about 58%.
Generally, it has 5 isotopes.
5 isotopes, they are equal in atomic radii. So
what about their masses? الماسس بتاعتهم بتبقى nearly small, فبيبقى generally the average atomic mass becomes small. So because of this, nickel, out of the increasing of the atomic
stable in the atomic.
Yes, it becomes small because it has 5 isotopes. The average mass is small. 5 isotopes.
8.6
yes.
About.
So it makes the total atomic mass of the nickel small.
Yes.
So it's out of the increasing of the atomic masses.
Exception in this.
Yes. Now let's transfer. So we discussed the atomic mass, the atomic radius, and then transfer to the density of these elements. Let's transfer. We discussed the oxidation states before in the beginning of our session. Let's transfer to the color or the catalytic activity. What about these properties?
Paramagnetic والmagnetism.
Yes, magnetic properties.
Okay.
Let's transfer to these properties, please.
Okay. Magnetism. Magnetism is the effect of the outer magnetic field on the elements. When the element attract or the ion attract to the outer magnetic field, we call this paramagnet. Paramagnet. Paramagnetism meaning that the element or the ion is attracted to the outer magnetic field. This is why when the element has unpaired electron in sublevel D, when the element has or the ion has unpaired electron in sublevel D, for example, Fe, argon 18, 26, argon 18, 3d6, 4s2. What about the number of electrons and arrangement of electrons in sublevel D? We know that according to Hund's rule, no pairing of electrons takes place until each orbital contains single electron. So it will be 5 electrons, then the 6th one. So here 1, 2, 3, 4 unpaired electrons. The magnetic momentum of this element means that it has 4 electrons. Magnetic momentum equals 4. The spin motion of the electron, single electron, makes magnetic field. The spin motion of the single electron makes magnetic field around it, and this can attract to the outer magnetic field. So the presence of unpaired electron makes the element paramagnetic, or the element is attracted to the outer magnetic field. The number of unpaired electron is called magnetic momentum. Magnetic momentum. What's about diamagnetic? Diamagnetism. Diamagnetism. Diamagnetic element, the element rebel with the outer magnetic field. Why? This element have no unpaired electron. No unpaired electron. Elements or ion, I said. For example, zinc. Zinc 30 or zinc ion. It will be argon 18, 3d10, 4s2. So D sublevel has 10 electrons. These electrons are paired. So the spin motion of the two electrons cancel the effect of each one. So it has no magnetic field around its elements or its atom. So it doesn't attract to the outer magnetic field. We call this diamagnetic elements. And magnetic momentum of this element will be equal 0. So when the element or the ion has unpaired electron, it will attract to outer magnetic field. When it has no unpaired electron in sublevel D, it will not attract to outer magnetic field, and it will be called diamagnetic elements. This is about the magnetism. And we say that the causes of magnetism due to unpaired electron, which make the spin motion of this electron make outer magnetic field around it. Number 2, what's about the...
We said that the unpaired electron causes the magnetic property, the catalytic effect, the coloring effect.
Okay.
3 of them because of the unpaired or paired electrons.
Okay.
We said that the unpaired cause the paramagnetism and paired cause diamagnetism. In unpaired cause a catalytic activity of these elements, so we can use them as catalysts. We
And
said
also-
why? Because they form temporary bonds with the reactants, so they give the chance for the reactants to react faster on their surfaces, on the surface of the catalyst, faster than being alone without a catalyst.
Okay.
Could we explain, please,
yes.
this point and
Okay.
explain the energy diagram for the reaction of H2O2, decomposition into H2O and oxygen?
Okay. Catalytic activity. As I may say that presence of unpaired electron, this can make a bond, or electrons make bonds with the atoms or molecules of the reactants. عفوا. For example, to explain this, let's take this example. Nickel, divided nickel is used as a catalyst in hydrogenation of oil. Hydrogenation of oil. At first, what's meant by hydrogenation of oil? We know that the difference between oil will fat in many points. These are liquid in room temperature, and these are solid. This is a short chain, and this is long chain of hydrocarbon, as we'll explain in hydrocarbon. But the main point, this has less number of hydrogen. We said it is unsaturated compound, unsaturated, because it has double bond or triple bond, as we'll see later. And this is saturated. In order to convert oil to fat, we must add hydrogen to oil. In order to convert oil to artificial fat, in presence of divided Ni, divided nickel. This is called hydrogenation or solidification, because we convert the liquid to solid, or hardening. How hydrogenation occurs? How nickel act as a catalyst in this experiment? Let's say that this is the surface of nickel. It has unpaired electron. Unpaired electron. And here the atoms or the molecules of hydrogen and oil. Hydrogen and oil. An unpaired electron can make bond with hydrogen and make bond with molecule of oil. Hydrogen and oil. Hydrogen and oil. So the concentration of molecules of these reactants increases at the surface. This is why. Because making bond between the unpaired electron of the catalyst and the molecules of reactants weaken the bond between the molecules themselves. So it is easy to concentrate the reactants at the surface, so the reaction will be faster. Oil will be combined with hydrogen, oil will be combined with hydrogen, and the catalyst is not affected, but it acts as a catalyst to increase the reaction, the speed of the reaction. Again, why nickel or the catalyst increase the speed of the reaction? Number one, presence of unpaired electron. So transition element is a good example for catalyst due to the presence of unpaired electron. Unpaired electron can make a bond between atoms and the molecules of reactants. Number two, the attraction between molecules of the reactants themselves decreases. So the concentration of the reactants increases at the surface of the catalyst. When the concentration increases, this increases the speed of the reaction. In absence of catalyst, it will need high energy. Why? Because the bond makes, or presence of the catalyst makes a bond to decrease the activation energy, the energy needed to start the reaction. It will be explained this terminology, activation energy, the energy needed to start the reaction at collision. Presence of a catalyst decreases the activation energy, so the reaction occurs faster. For example, when we make a diagram to take the reaction of H2O2 in presence of manganese dioxide, it will be converted into water and oxygen. H2O2 hydrogen peroxide is converted into water and oxygen. So in absence of a catalyst, it will be, this is high, this is the diagram, this energy, and this is the time. This is between reactants with products, heat content of reactants and products. This will be activation energy in absence of catalyst. But in presence of catalyst, it will decrease the activation energy. This distance is the activation energy in presence of catalyst. So the catalyst decreases the activation energy to increase the speed of the reaction.
The left property is the colors in the transition elements. Why some transition compounds are colored and others are colorless?
Okay.
Actually, the three properties related also to the unpaired electrons,
yes,
the magnetism and the catalytic activity and the colors.
Well, also it will be transition elements.
Yes.
Let's to give another example or two examples about the using of catalyst. As we know, in the Haber-Bosch method, nitrogen react with hydrogen. We studied this in the last year. In presence of iron or molybdenum, divided iron or molybdenum as a catalyst to get NH3 ammonia. We know that 500 degrees Celsius and 200 atmospheric pressure. But in presence of divided nickel or divided molybdenum, nitrogen combine with hydrogen to form ammonia. This is called Bosch methods or Haber and Bosch methods.
Also the contact process to prepare sulfuric acid, we use vanadium pentaoxide as a catalyst.
Yes, yes. We know that S can react with oxygen to form by heating SO2.
Yes.
This when dissolved in water, it doesn't give sulfuric acid, it gives sulfuric acid, H2SO3. But when SO2 combine with oxygen in presence of vanadium pentoxide, V2O5 vanadium pentoxide, to give SO3. To balance the equation, we put 2. So the vanadium pentoxide is oxidized, is catalyst used to convert SO2 to SO3, or help to convert sulfur dioxide to sulfur trioxide. Sulfur trioxide dissolved in water, it gives sulfuric acid. This is called contact process, H2SO4, one of the process of preparing sulfuric acid in industry. So we used also vanadium pentoxide, V2O5, as a catalyst.
Actually, the word contact, due to the contact between the two gases, sulfur dioxide and oxygen, on the surface of the catalyst.
This is called.
Now, to the last property related to the unpaired electron, but still we have another properties, metallic properties, shiny, malleability, ductility. This is, we didn't discuss it yet, but the last one due to the unpaired electron is the colors. Why some compounds are colored?
We said about ductility and the brightness or lightness. This is studied, this property of metals in last year. Yes.
Just we stress on it for the students in this year. Okay, what about the colors?
About the color. Also, as you said, that the color due to the presence of unpaired electron. When the element or the ion has unpaired electron, it will be colored. When it has no unpaired electron, it will be colorless. Okay, let's to explain why this occurs.
Actually, I'm sorry for interruption.
Yes.
The colorless due to D0, D10, or unpaired electron S&P sublevels.
Yes.
So these are the colorless. Okay.
Let's when empty and when all the
completed paired, or S&P are contain unpaired, but in S&P not in D.
Okay.
Okay. Let's transfer to the colors.
Let's to explain the compound of cobalt, for example. Cobalt positive 2 or positive 3, whatever. Cobalt has unpaired electron. Cobalt positive 3 has unpaired electron. We know that cobalt argon 18, 27 3D will be has 6 electrons. Why it loses 3 electrons? 2 from 4s and 1 from 3D. So 3D One, 2, 3, 4, 5, 6. It has unpaired electron. It has unpaired electron. We know that the light has many colors. White light, visible light, has many colors. Each color is a type of energy. If the energy of any color, similar to the energy needed to transfer the electron, unpaired electron, the electron will absorb the photons of this color. Again, when a color, any color of the visible light, equal the energy of this color equal to the energy needed to transfer the unpaired electron, it will absorb this color. And the rest color of the visible light will be complementary. It's called the complementary color. The element appear by this complementary color. For example, cobalt seems to be blue. Why? Because it has unpaired electron. The energy of orange or red-orange color needed to equal the energy needed to transfer this unpaired electron. So the cobalt absorb the orange color and seems to be by the complementary color, which is blue. This is about the element which has a color. For example, element which has blue, مثلا, for example, copper has blue, has unpaired electron. طب what's about absorb the color and seems to be by the complementary, which is blue? What about the element with white color and black. When the element absorb all the visible light, all the color of the visible light, it will be no reflect any color. It will be black. But when the element reflect all the color, not absorb any color, it will be white, because it reflects or leave the all color of the visible light. So here we have 3 points. Will the element be black? When it absorb all color and don't leave any color, it will be black, seems to be black. And another substance, the white substance, they reflect all the colors, they don't absorb any color. And the last one, colored element, which absorb some photons of the light, and the rest of the light, which is called complementary, appear by these elements. So many elements have transition elements have many colors due to the presence of unpaired electron of these elements. This is about the color and the effect of the color.
The left properties are the metallic properties. We said that they are, some of them are hard, all the metals are hard. They are shine, malleable, and ductile, good conductor of heat and electricity, except mercury. We know that it is liquid, right?
Yes.
Now, what about, we have also they have high melting point, yes, due to they have losing electrons from the 4s and 3d, or sharing by these electrons in metallic bonds. So this metallic bond make the metal strong, so it needs great energy to be melted, so they have high melting point. These are the main properties of the transition elements. Left one is the activity. We have moderate, high activity, less activity. Moderate, we have high activity, scandium.
Scandium can react strongly with water, can replace hydrogen of water.
Moderate, iron, أو intermediate iron, less activity, copper.
Copper. We know that iron, yes, can react with hot water.
Yes.
While copper cannot replace hydrogen of water or of acids.
By this way, we finish all the properties of the transition element. Thank you, Mr. Muhammad, for being with us.
Thank you.
Thank you, dear students, for being with us. We'll wait for you for the next session. Send your question on our page on the Facebook. Assalamu alaikum wa rahmatullahi wa barakatuh.